So as I said, thank you very much for the very nice introduction, and thank you very much to Studium Generale to have me here in Utrecht. It's my first time in this amazing venue, so I hope you're all going to enjoy the talk that I'm going to give you today, which is going to be about the secrets of superhero science. But in order to get you all, let's say, in the zone and in the superhero mode, I'm going to have everybody have a very, very quick look at this.
What's up, guys? Wait a minute. You guys aren't the real Avengers. I can tell Hulk gives it away. Oh, that was awesome. Is Liz the new top?
No, we've seen that before. Never with that skirt.
Should probably stop staring before it gets creepy, though.
Too late. You guys are losers.
So, to become an Avenger, are there, like, trials or an interview?
Just don't do anything I would do. And definitely don't do anything I wouldn't do. There's a little gray area in there, and that's where you operate.
Oh.
All right?
That's not a hug. I'm just grabbing the door for you. All right, kid. Good luck out there.
Listen, I know school sucks.
Peter, you still with us? Yeah.
I know you want to save the world. But you're not ready yet.
You're the Spider-Man.
No, I'm not. I'm not. This is just a costume. This is from the ceiling.
Stay close to the ground. And stay out of trouble. Forget the flying monster guy. There are people who handle this sort of thing.
I'm sick of him treating me like a kid all the time.
But you are a kid.
This is my chance to prove myself. Peter, what is going on with you? I'm really sorry. I'm so busy. I'm slammed.
Don't mess with me, because I will kill you and everybody you love.
So that was a trailer for Spider-Man Homecoming, and that film is going to be out in July, and I got to say I'm really, really excited about it. Now, this is the third version of Spider-Man. I'm sure some of you have seen Spider-Man with Tobey Maguire from the start of the last decade, and then there was Andrew Garfield at the start of this decade as the second reincarnation of Spider-Man, and Tom Holland is the third one, and we saw him first as Spider-Man in Captain America Civil War. Now, Captain America Civil War is the 12th highest grossing film of all time. It has made $1.1 billion at the box office. And just to give you an idea of the type of films that it's in the same vicinity of, in 11th in the all-time list of grossing films of all time is Minions. I've never seen Minions, so I've been told I should watch it. Now, superhero films are big business. And in my opinion, all of the big superhero blockbusters that we're currently experiencing at the moment, such as Logan, which is in the cinemas at this very moment, kind of all kicked off with the film X-Men from 2000, the Bryan Singer-directed film concerning the characters Professor Xavier and Wolverine, who have come to be some of the most memorable and have appeared in so many films at this stage that it seems like Patrick Stewart was born to play Professor Xavier, and Hugh Jackman was only ever meant to play Wolverine and Logan. Now, I don't want to discount, of course, the older superhero films before this. This one I have pointed out because this had a big budget and it was the one with big expectations and it succeeded. Of course, there was Superman before that and the Batman films from the late 80s and 90s. I got to ask a question. How many people here have seen Superman? Hands up, from 1978. The very first Superman, right? That's almost half. So for those who haven't seen it, I'm sure the reason you haven't watched it is because there's no special effects and it's clear that he's not carrying a car and he didn't move any particular building. But I encourage you to watch it because it's a fantastic story. Now, this year, we are in the middle of a bunch of superhero films, and already we've seen Logan come out. And next month, we got Guardians of the Galaxy Volume 2, which I have to say I'm eagerly anticipating. I think it's going to be fantastic. And then there's a Wonder Woman film, which is coming out in June. Added to that, then there's also Thor Ragnarok, is going to be out later this year, and Justice League, as well as the aforementioned Spider-Man Homecoming. Now, for as long as I can remember, I have dreamt about having superpowers. So I've been always, as a kid, I've been attracted to superheroes in terms of what they can do and their amazing powers and abilities. And when I became a scientist and when I started to go and watch these amazing superhero films such as X-Men, which came out just as I was doing my bachelor's degree, I remember walking out of the theater and thinking, how could this happen? I mean, is this possible? Could I have that ability? Could we in the future have these powers and abilities? And from that point forward, I have been started asking myself questions and started writing down these questions until a point where I figured that I could give my answer to enough of those questions. And that's why I wrote a book called The Secrets of Superhero Science. And in the book, they're my answers. They're not the answer towards creating superpowers. It's what I hope people might turn to in the future. Now, I have to ask, hands up, how many people here have dreamt of having a superpower? I hope pretty much everybody. Everybody here wants to have a superpower. I can tell you right now, the one I want to have, flight. I would love to be able to fly, be that with an Iron Man suit or not with an Iron Man suit. That would be absolutely amazing. I think that would be a fantastic power to have. But there are many scientists out there at the moment who are working on amazing projects that, believe it or not, could have applications in the future towards creating superpowers. Now, they're not necessarily all dedicated towards building superpowers in a laboratory, but as a nice spin-off, fingers crossed, I hope, that some of these amazing research projects could lead to applications in superpowers. So who's to know? There may be someone out there who's doing
Day 11, test
exactly what Tony Stark
37,
does.
configuration 2.0. For lack of a better option, dummy is still on fire safety. If you douse me again and I'm not on fire, I'm donating you to City College. All right, nice and easy. Seriously, just going to start off with 1% thrust capacity. In 3, 2, 1.
So that's Tony Stark in the process of building the first Iron Man suit, or even the second one, to be actually exactly correct. Now, the thing is, when people see technology emerge into the world, they forget that there's a lot of testing that has to happen in the background or for months in the lead up to the release of some piece of technology. Tony Stark just didn't invent the Iron Man suit in one day. He had lots of problems, and this is one of the scenes demonstrating some of the testing that he had to put into designing and creating this technology. Now, Tony Stark himself built the Iron Man suit. That's a power that he has built, a technology that he can put on, and he can do things that we don't see in the everyday world. But the other three characters on this slide, which are Storm from the X-Men, the very, very memorable Colossus, who is one of my favorite characters from Deadpool, and Sue Storm, the Invisible Woman from Fantastic Four, they have their powers in a completely different way than Tony Stark. And it comes down to what's inside of them. It comes down to their DNA and their genetic makeup. In some way, their DNA is different from ours, and that's why they have their powers. In the case of Storm and Colossus, they have genetic code in their DNA, which we don't. That's the simple explanation that is given in the comic books. And to kind of elaborate on that, when Stan Lee was coming up with the X-Men, he had wanted to make the origin story stuff easier for himself, because every time he introduced a hero, he had to come up with a plausible origin story. So he decided to just introduce a band of characters and say they're all mutants. There we go. So that's the explanation for everybody that appears in the X-Men universe. Now, the Invisible Woman, she gets her powers depending on which version or which film you've looked at, or which comic book, using interdimensional travel, or in the very first film, it was cosmic rays and exposure to those. And I can tell you right now, if anybody suggests you go on holidays to catch some cosmic rays, politely refuse, because they will not give you superpowers. They will most definitely kill you. So do not accept that invitation. Now, the reason that the X-Men have their powers, such as Wolverine, such as Storm and Colossus, is because their bodies are producing proteins that we don't. And the reason they produce these proteins is because it's in their genetic code to produce these proteins. And we don't have that particular piece of genetic code. So everybody in this room has got some sort of, has DNA, and their DNA is in some way, everyone here is different. So everyone is unique, and your DNA, on the very, very smallest scale, is different from everybody else. So if the X-Men's DNA is different from ours, could we make our DNA like the X-Men's? So the question I'm asking is that could we include the X gene, which is the gene behind the powers of many of the X-Men characters, in fact all of them of course, in our own DNA? And of course the secondary question is, would we want to? Well, the first thing we have to address is, do we have a tool out there that can actually allow this and help us to do this? And the answer is, at this very moment, yes, we do. We have one that's very, very popular, and a lot of people are using it at the moment. It's called the CRISPR-Cas system. And the CRISPR-Cas system, what it does fundamentally is it cuts your DNA at specific locations. And it will do that for two reasons. First of all, it could be used to destroy genes associated with diseases, such as blood disorders or cancers. Secondly, you might want to remove a gene and insert another gene in its place. So let's imagine a distant future where we have overcome ethical, political, governmental policies in relation to the genetic modification of humans, and you have at your disposal the CRISPR-Cas system and a library or a collection of all of the superhero genes that you've seen in the superhero films. Potentially, the CRISPR-Cas system could be used to merge those to allow you to produce or engineer people like the X-Men. Now, of course, I will highlight this again. This is all very, very ethically controversial, so that would have to be addressed before we ever do that. But the CRISPR-Cas system has already been used to change other things, because we're not the only species on this planet that has DNA. So, for example, in the United States, a group has changed a mushroom using CRISPR-Cas so that it never goes brown, ever. So that when you go to the shop, it always looks white, it always looks fresh. Of course, then it begs the question, how do you know when it's not fresh, if it's not going brown? Another group have taken the CRISPR-Cas system and modified the DNA of zebrafish so that instead of growing fins, they grow limbs. And this is how powerful this technique is. So for that particular applications, they can get full ethical approval, of course, for this research. But once we start to go towards people, it's going to be a different story. But imagine we have all of that. Maybe you might want to do the following. This is a really recent paper. I believe it's only published in the last few weeks. And it's about natural fluorescence in frogs. And they've identified the molecules behind this fluorescence. So fluorescence is when something absorbs wavelength at a low wavelength and then it re-emits it at a higher wavelength. And this frog appears to fluoresce and give off ultraviolet wavelength. Now, maybe you might want to use the CRISPR-Cas system to modify other species to give this particular ability. And in fact, some parrots can actually do this already. Maybe you want cows to fluoresce so that you can find them at night in your field, or whatever other reason that may be. But getting back to the idea of actually putting a power from one of the X-Men, we can turn to salamanders. Now, last year there was a paper published in PLOS ONE where they identified the RNA sequences behind the regenerative powers of salamanders. So salamanders is a species that if you chop off their tail or their legs, they'll grow back. In time, of course, not instantaneously, but over time. So we now have identified the RNA sequences. Imagine if we could take those RNA sequences, use CRISPR-Cas to modify human DNA and insert them in our DNA. Well, what actually we'd be doing is we'd be playing the part of Dr. Kurt Connors from the Spider-Man films, who, in an effort to grow his own arm back, decides to turn to lizard DNA and includes it in the serum, which it does allow his arm to grow back, but he, in the end, he actually turns into a giant lizard. So he didn't really account for that little side effect. So clearly, this is an example to demonstrate that there is a side effect of this approach. But because salamanders can regenerate, we have our source of this regeneration gene. So maybe we can use CRISPR-Cas in the future to accelerate the human ability to recover from injuries so that we can regenerate and heal faster. Maybe not to the extent of Wolverine, who is seen healing within a matter of seconds when he's shot by bullets. So he could be shot by a bullet and within 10 seconds his body has rejected the bullet and it has healed over the wound completely, and it's as if he has never been penetrated by the bullet. So maybe that's a little bit far off. But this is the type of length scale that we're dealing with. This is, anybody know? Anybody have an idea what the red things are in this image? Anybody? Yes, somebody said blood cells. They are indeed blood cells. So they're not just any blood cells, they're my blood cells. So I have some friends who work in Maastricht. They're researchers in regenerative medicine, but they're also in bioart. And they took a sample of my blood, and they put it through an SEM, and they took this image. Also in this image, which I really, really liked, you can see my white blood cells. So that's my good guys fighting the bad guys trying to invade my body. And all of this is on top of spider silk. And that's why the colors are red, blue, and white, trying to capture the colors of a Spider-Man suit. But the scale that we're looking at here, red blood cells is about 7 micrometers, which is about 7 millionths of a meter. So that is the scale that we need to look at and manipulate if we want to create the X-Men and produce these proteins in the future, if we want to have the powers of the X-Men. But this is the biological route, and there is a technological aspect to it. But now what I'm going to show you is a number of technological paths to superpowers. So if we didn't want to have to modify the DNA of somebody, what if we just said, you know what, I want to generate a technology that will give me a power? Just like this. And that's Iron Man in Iron Man 2, putting on his Iron Man exoskeleton suit at a Monte Carlo event. And this is what I'm talking about in terms of creating technologies to give us superpowers. And I'm not talking about 50 years, 100 years into the future. I'm talking about in the next 10 years. And in this case, you don't necessarily maybe have to deal with the same level of ethical issues that you would when you're doing biological editing or genetic modifications. But again, of course, you have to take the safety of the wearer into account, naturally. Now, invisibility is a power I'm sure that many people would like to have. I remember the first time I gave a talk, I wanted to be invisible, or I wanted the audience to be invisible, at least so that either way we couldn't see each other. That's how nervous I was. Now, invisibility, some people think is a dream. It'll never happen. But the key to invisibility is this. If you just stop light, reflected light from an object reaching your eye, then you shut down the biological process that is vision and sight. Because once the light enters your eye, it hits the retina, generates electrical impulses, which travel down your optic nerve into your brain, where it then is interpreted as an image and allows you to see. But if you prevent the light from getting to this point in the first place, then you've cracked invisibility. Now, the next image I'm going to show you is not photoshopped. This is a PhD student, he may have actually graduated at this stage, from the University of Rochester, and they developed an invisibility cloak, which is they call the Rochester cloak. The instructions are on Wikipedia to build it. So if you want to build it, jump onto Wikipedia and you can find it. And this is a real invisibility cloak. I have not photoshopped this image. This is a real image. And what they did was they cracked invisibility in a very simple way. They'd said, well, you know what, let's use common optics. So lenses like the lenses of my glasses, or the lenses that are in your eyes. And they took 4 lenses and arranged them in a particular configuration. And when they do that, it allows them to make some object appear like it is not there, or to create a cloaked region, allowing you to cloak part of a particular object. So in this case, it's been used to cloak part of the student's face. And in the paper itself, and there's all the details for the paper, there's the title if anyone wants to read it. I've read the paper, it stands up scientifically. There's another example on the right-hand side where they just took a hand and they put it through this configuration of lenses. Now, of course, as a good scientist, you want to test this. So I said, you know what, I'm going to build this invisibility cloak. Because to build it would cost you about €1,000. Okay, it's expensive, but not as expensive as you might think. And I did that, and I built it 2 months ago. And I showed this at a particular conference in Veldhoven. And what we did was we set up this configuration of lenses. You'll notice there's a Lego bridge in between 2 of the lenses, and there's a green part at the center of that bridge. And then at the end of the lens, behind the last lens, you see an Ant-Man figure. One of those Ant-Man Funko figures, the big giant head. So I wanted part of his head to be covered by the bridge, but when you look through the lenses, you should be able to see that part of his head. And that's exactly what we found. And I was very happy to see that. So I've proven that what they showed in the paper holds up. Now, you might be thinking, well, that we're still a long way off actually having an invisibility cloak with this technology, and I completely agree with you. But imagine if you went to the year 1903 and Orville Wright had just come off the Wright Flyer 1 after flying a height of 10 meters in a field for a distance of 60 meters, and you walked over to him and you shook his hand and you said, Orville, that's amazing, congratulations, you must be exceptionally proud of what you've just done, because in less than 70 years, because of what you did today, man is going to walk on the moon. What do you think? Is he going to laugh at you? Would he? I don't know. Would he think it was obscure and preposterous? Maybe. But imagine a future in maybe 20, 30, 40, 50 years' time that there is a suit that you can wear that is made of 4 optical lenses, and when you wear that suit, it allows you to be invisible. Now, Spider-Man has many incredible powers, and one of those is his spider silk. So I'm going to have a little footage here just to show you him using the spider silk.
Wow, it's so weird how you run into people at the airport. Don't you think that's weird?
Definitely weird.
Hear me out, Tony. Captain.
Your Highness. Anyway. All right. I've run out of patience. On to ruse! Nice job, kid.
Thanks. Well, I could have stuck the landing a little better. It's just a new suit. Wait, it's nothing. Mr. Stark, it's perfect. Thank you.
Yeah, we don't really need to start a conversation.
Okay. Captain? Big fan of Spider-Man?
Yeah, we'll talk about it later. Just...
Hey, everyone.
Good job.
One of the best things about that clip I really love is that Spider-Man, who's a superhero, just admitted to Captain America, who's also a superhero, that he's a fan of Captain America. I do like Captain America, so I'm happy to hear that Spider-Man, who's a superhero, also likes Captain America and what he does. Now, spider silk, as used by Spider-Man in the films, is a protein, and it's also one of the toughest natural materials on the planet. It's actually tougher than Kevlar, which is the traditional material that's used in bulletproof vests. So if we wanted to use spider silk as an alternative for bulletproof materials, well, then we have to make sure we can produce enough of the stuff. Now, I don't think it's practical to set up a factory with 1 million spiders and to extract spider silk from those 1 million spiders round the clock. I'm not sure you'll actually collect enough of the spider silk to do that. So I think about 15 years ago in the United States, some scientists came across a very, very viable solution. They created a spider goat. Now, what is a spider goat? Well, a spider goat is a genetically modified goat that has been modified in such a way that when you milk the goat, it produces not only milk, but also the protein behind spider silk, which can then be extracted from the spider silk, electrospun into the traditional strands of spider silk, and then used for whatever application you want. And by the way, I should also point out that it is perfectly healthy to drink the milk. Absolutely, milk is a protein, spider silk is a protein, they're both natural products, it's not toxic. I always like to point that out because a lot of people are disgusted by the idea of drinking milk from a spider goat. Now, this spider silk has been used to create bulletproof spider silk skin. This is Jalidi Asadi. She's from BioArt Laboratories in Eindhoven. And a number of years ago, she was working on a project and developed a project with the aim of creating a material consisting of human skin cells and spider silk that's bulletproof. And they succeeded. So when they built it, they found that it is bulletproof to low-velocity bullets. So velocity bullets about 170 meters per second. When they went to the higher velocity of traditional rifles, which is 329 meters per second, they found that, well, it goes right through. So the question is, well, if they include more layers, could they maybe withstand bullets at higher velocities? And just to demonstrate the bullet being stopped by the skin, here it is. And this testing was done at the forensic laboratories here in the Netherlands. So there's the bullet stopped by this bulletproof skin. So imagine if in the future you could actually buy a suit that could give you impenetrability. But added to this, what if the same suit also allowed you to be invisible? Why not? I mean, we're combining this stuff together. In fact, with Tony Stark, when he built the Iron Man suit, he combines multiple powers in the same suit. So why not think about doing that? And the thing is, I got to ask, how many people here would like to have a spider goat at home? That's, a few people. By the way, there are herds of these. It's not one. There are herds of spider goats. And, of course, when they did this experimentation, they received full ethical approval in the United States. Now, I'm going to talk about what I believe is the ultimate wearable technology. But in my opinion, it's also the ultimate biosensor, and that's the Iron Man suit. And I'm going to demonstrate to you how it is the ultimate biosensor. Just have a quick look at this.
Wanda, I think you hurt Vision's feelings.
You locked me in my room.
Okay, first, that's an exaggeration. Second, I did it to protect you. Well, first time for everything.
Made you look.
Multiple contusions detected.
Yeah, I detected that too.
So that's a scene from Captain America Civil War where Iron Man has had quite a few cars dropped on top of him by the Scarlet Witch. And the suit instantly tells him and reports on injuries in his body. And he sarcastically, of course, tells the suit, well, I've already picked up on this. Clearly, I can feel that because I'm the person inside the suit. Now, this is why I believe this is the ultimate biosensor. And this is where biosensing could go. Instantaneous feedback on functions within the body at any moment in time. Now, I run, so I try and run, and I've done a couple of marathons. And when you run, sometimes you have to wear those really uncomfortable heart monitors that are around here, or you might be lucky to have one on your wrist. So we are, even in everyday life, engaging with biosensors. And there's a competition, a student-run competition in TU Eindhoven called Census. And what their principal aim is to do is to develop biosensors that are non-invasive. So what they're doing with in this competition is that they bring in a number of teams from other universities around the world, and typically around the world. This year is actually around the world, and the first iteration was five teams from around Europe, with the aim of building a biosensor that anybody can use at home. So in the first competition, the aim of the teams was to build a biosensor that can monitor creatinine, which is a biomarker, or a toxic biomarker, that if it's not filtered out of your body by your kidneys, can prove fatal. So for those who have, for example, kidney issues and want to get continued monitoring of their function of their kidney, what better way to do it than at home, in the comfort of the home, and by themselves using a trusted and reliable method. So the team in Eindhoven, for example, they built a device which is very, very small, where you take a very small sample of your blood, you put it in a white holder, you insert this into a device, the blood then undergoes a biochemical reaction, it then creates a color change. You take your phone and you plug your smartphone into the top of the device, take a photo of the color, and it then tells you instantly, based on that color and on some sort of a scale, how much creatinine is in your body. I think it's ingenious. And this is where we should be going with biosensors, because the Iron Man suit has got this and more. Now imagine a future where if we all had Iron Man suits at home, but they weren't used to fly around or fire weapons, but instead we used them to step into, to give your body full diagnostic testing of any bodily function, so you don't have to go to the hospital anymore and queue in waiting rooms, no more going to your GP and waiting, and all the data that's collected from the suit is relayed to your doctor, and based on that, they decide on whether or not you should actually have to go to hospital or not get any further medical treatment. Now, the last thing I want to talk about in terms of technologies is what is the Iron Man suit made from, because if we can't replicate that material, then, well, we're kind of stuck in terms of making the suit. So I'm going to let Tony Stark tell you exactly what the suit's made from.
You've all received the official statement of what occurred at Stark Industries last night. There have been unconfirmed reports that a robotic prototype malfunctioned and caused damage to the arc reactor. Fortunately, a member of Tony Stark's personal...
Iron Man, that's kind of catchy. It's got a nice ring to it. I mean, it's not technically accurate. The suit's a gold titanium alloy, but it's kind of evocative, the imagery, anyway.
Here's your alibi.
So there you go. He told you in the clip exactly what the suit is made of. It's not made of iron. It's made of a titanium gold alloy. So in terms of titanium and gold, I'm sure many people here know that, like oxygen, gold and titanium are atoms. And if you've never seen titanium, I've just included a block of it there just to give you an idea of what it is. Now, traditionally, titanium gold as an alloy itself is normally used in jewelry, or you might find it in fillings for your teeth. In terms of titanium itself, it can have many applications, such as alloys used in hip replacements, and also in terms of landing gears in aircraft. Now, the thing is, a lot of the best stuff in science is discovered accidentally. And this is what happened, exactly what happened last year with a brand new titanium gold alloy. So there were some researchers who were experimenting for other reasons on titanium and gold, and they ended up combining the two materials together at a very high temperature. And as a result, they ended up producing an alloy that was many times stronger than existing steel alloys, and also would outperform those steel alloys. What it actually presents is the material that could potentially be used in an Iron Man suit. So for a long time, many people debated, well, you can't use titanium and gold. They don't behave or have those properties. But the hardness of this material that's been produced may actually mimic the properties that we see in the Iron Man suit in many of the films, and may offer the wearer the level of protection that it does Tony Stark when he's wearing the suit. Now, I've spoken here about a number of superpowers, and as I mentioned earlier on, I don't believe, I hope, fingers crossed, there are no dastardly scientists out there who are working in secret on the creation of superpowers behind closed doors, and they're using the grants for other reasons. But what I firmly believe is that, as a scientist, our duty is to do constructive research that can benefit mankind and benefit society. And that should be the primary goal. But given my infatuation with superpowers, I would really like that as a little spin-off or a secondary result. Wouldn't it be fantastic if we had superpowers in the real world thanks to current scientific research that's happening right now? I also, sorry, I'm after losing the slide there. My apologies. So I also have to ask the question, though, if I set up a research institute that was called the Secrets of Superhero Science Research Institute, how many people would like to come and work for me to create superpowers? Some people are kind of shy. I don't know if I want to admit in public that I want to create superpowers, but some of you did, which is great, fantastic. Send me your CVs, I'll have a look. We'll start applying for grants as soon as possible. I get full credit from the start for all ideas, and then within 2 or 3 years, I'm joking, of course. Science isn't about one person, it's about collaboration and people working together, and that's what it would be. But I also have to ask a related question. So I've remembered the people who had their hands up for the last question. How many people here would, if I gave them a superpower right now, would use it for evil? Hands up. You'd use it for evil. Is it because if you have a superpower and you have an advantage over people, you can have more fun, it's all about the fun. That's what most people say. When I ask them that question, most people say it's all about the fun. You can break the law and, you know what, who cares, I've got a superpower. So this is a picture of me taken last year after I released my first book, which is Secrets of Superhero Science, and it just shows me in a laboratory in TU Eindhoven, and what it does is it combines the two aspects of what my message is and what I'm trying to communicate. It's about merging popular media, about merging superhero films, which I'm sure many of you here have seen, I hope at least one, if not all of them. In many cases, I'm sure people have seen all of them. And science itself. And here I am reaching out wearing my Spider-Man glove. I've got my Spider-Man mask is on the shelf above me. You might, if you're eagle-eyed, you might see the Spider-Man fluid also in the background. And for those who are extra eagle-eyed, you might even see the spider over my shoulder on the right-hand side of the image. And the core message of this is that, of what I'm trying to get across here, is that science can provide answers to many, many things. And what I'm trying to do is to attract people into science and demonstrate to them that, science is really exciting, it's really interesting, and the problems that you could be working on could lead to the emergence of superpowers in the future. And that's the people who are sitting here in front of me, because I'm not going to create them, but I'm hoping that people here will walk away today and go, you know what, I'm going to become a research scientist, or I'm going to continue with my research, I'm going to change direction, I'm going to aim for something that could give me a spin-off of superpowers. If you want to know more, you can find about me. You can find it from my website, which is bwscience.com, and about my other activities and what else I'm involved in. So this has been the Secrets of Superhero Science. I've been Barry Fitzgerald. I hope you've really, really enjoyed what you've had to hear. And thank you very much for listening.